Hello guys, welcome back to Manala's Arc. I hope you've all been well. So I'm creating this video, in fact not only this video, I'm creating a playlist for grade 10 to help them prepare for June exams. Now this playlist is going to be divided into topics. I'm teaching you now how to study with past papers. Remember what we said in class. Whenever you study for past papers, you don't start a question paper and finish it in one go. You are going to download your question papers for the past 5 years or maybe for the past 6 years. So now in this situation, I'm looking at past papers from 2024 up until 2018, right? I'm going back in time like that. In this past papers, I'm only looking at June exams from the Gauteng province. And then I'm going to attack each topic at a time. So I'll look at 2024, the topic of number systems, then 2023, then 2022, 2021, 2020, 2019, and 2018. I attack the whole topic. By the time I get to 2018, I will have understood all these topics, right? So I hope you understand by that. So don't hope that this video will attack everything about a June exam. Right now, I'm only focusing on question 1. Because if you study question papers, you'll see that there's a pattern. They won't put this topic in question 8 or question 5. No, this will always be the first question if it's there, right? Okay, let's get to it. So the first question says, it's a question from 2024, June Gauteng. And then it says question 1. Now, these questions are like tricky in a way. They're very easy. Once you understand them, these are easy marks for grabs. But you first have to understand them, right? And once you understand them, you do a lot of them, you'll get the hang of them. So the first question says, if x is an element of 0, 1, 2, 3, and 4, write down a value of x such that k is equals to 9 all over 4 minus x, all under root. This is either undefined, is rational or irrational. Now, when you listen to that English, it might sound confusing, but trust me, it's not. You have to know these things. The more you do them, the easier they'll be for you. Firstly, I'm going to start with the situation of undefined because we have to get through that. So, for me to get an undefined situation, I'm going to put it here. For me to get an undefined situation, I must have a negative root. Right? Or 2, I must have a denominator of 0. So this will give me an undefined situation. At any point where I land with a denominator of 0, then that is undefined. Or if this whole sum under a square root is negative, then that's undefined. So they're saying these are my x values. I'm going to substitute all of them into this and then categorize whether the answer I get is undefined, is rational, or irrational. I'm going to answer all these questions at once. I hope we're good. Right? Now, let me start with the substitution. Now, remember, I'm substituting my x values into this. Right? So I'm going to start with the first value there. I'm going to say, I have 9 all over 4 minus. Now remember, they gave me a list of x values. The first x value is 0. Let me cancel it. I put a 0 here. What am I going to get? This is going to give me the square root of 9 over 4. Now the square root of 9 over 4, what is that? Now let me tell you something. A situation like this, I know you're going to make mistakes. Please take out your calculator and try to solve this with a calculator. So I've put that on a calculator. As you see, guys, I'm not ashamed to use a calculator. I've put it on the calculator. The square root of 9 over 4. I put my equal sign there. I'm getting what? 3 over 2. I'm not getting error. I'm not getting syntax error. I'm not getting a surd. I'm getting a clear fraction. Now, once you get a clear fraction, that is very rational, right? So I'm going to put it here. I'm going to say, oh, what was the fraction? The fraction was 3 over 2. So let me put it here. 3 over 2. I'm getting a clear answer there, a very rational number. So which means when I substitute x here, when I substitute an x of 0, I'm getting a rational number. So that's my answer there. You see that? I make another substitution now. So I'm going to the next value, 9 all over 4 minus, the next value is 1. So I'll substitute 1 here. And let's see what I get. I'm going to get the square root of 9 all over 4 minus 1, that is 3. And this is the same as the square root of what is 9 over 3, that is 3. So this is a third. I'm ending up with a number like this. This is a third. And once I get a third, that number is irrational. So it means now when my x is 1, I'm getting an irrational number. So I'm going to put it here. When my x is equals to 1, I'm getting an irrational number. So I'm allocating it to irrational. See that? Next part. I'm going to say, taking the same value, 9 all over 4 minus, the next value is what? Is a 2. So I'll put a 2 here. Right? So I'm getting what? I'm getting the square root of 9 all over 2. Now, once you put this on a calculator, don't be lazy, guys. Put this on a calculator. I'll do this with you step by step. So I have 9 over 2. And then I'm getting, you see that it doesn't end with a perfect fraction. It ends with a root still. It ends with a third. So this is very irrational because it ends with a third. So which means now my answer here is a third. I don't even care even what's the answer. My answer is a third. So I know that if I substitute x as 2, I'm getting an irrational number. So I'm going to put it here again. When my x is equals to 2, I'm getting an irrational number. So I'll put it there. Right? Next substitution. If I have 9 all over 4 minus, my next value is what? My next value is 3. So if I put a 3 here, I'm getting the square root of 9 all over 4 minus 3, that is 1. This is the same as the square root of 9. The square root of 9 is the same as 3. Now 3 is such a perfect answer. Very rational. So which means because I'm getting a rational number, it means when I'm substituting 3, my answer will be rational. So I'm going to put that answer there. When I substitute x as 3, my answer is rational. You see how easy is that? Beautiful. Next part. I'm going to substitute 4 now. So I'm going to say the root of 9 over 4 minus, substitute what? 4. Right? This is going to give me now what? It's going to give me the square root of 9 all over 0. Now, if you put this on your calculator, you're going to say the square root of 9 over 0. I put 0 here. Then press equal sign. You get what? Math error. So it means this is undefined. So basically it's saying now, if I substitute a 4, I'm getting undefined. Now look at that. You've answered all the questions. 1 mark there, 1 mark there, 1 mark there. Easy as that. How nice is that? So you can go back and rewatch this video there and see if you understand those parts. Make sure you understand them. Right? Now I'm going to the next paper. The next paper is a paper from June 2023. This is a very nice paper. Now look at that again. 2024 question 1, you are answering that topic. 2023 question 1, you are answering the same topic. So expect to see this in question 1. We are predicting the paper now. Right. So what's happening here? The first question says, for 2 marks, between which 2 consecutive integers does this number lie? Interesting, right? 1.1. 1.1. We are going to say that we have negative root 69. Right? Now, 69 is not a perfect square. We know that. Right? So we need 2 numbers that are perfect square coming before and after 69. Right? I'm going to write them here. A number that comes before 69 as a perfect square is 64. This is a very much perfect square. Right? Let me erase this circle around it. The next number that comes as a perfect square after 69, immediately after 69, is going to be 81. 81 is a perfect square, right? I have 64 as a number that is a perfect square coming here, and I have 81 as a number that's a perfect square. Now, bear in mind, this root now is negative, so which means I'll have to attach a negative here, and I'll have to attach a negative here. Do you see that? Now, what happens? What happens is that I need to put a smaller number on the left, and I need to put a bigger number on the right. Right, so between negative 81 and negative 64, the bigger number actually is this one, and 81, negative 81 is the smaller number because it's more negative. You see that? So now I'm going to rewrite it here. I'm going to say, let me just put my values here. I'm going to say now the root of negative 69 is found between the following values. It's found between, what is the smaller number? Negative 81. And I'm going to put this under a square root. And it's also found between negative 64, because this is a bigger value, right? Then I put those under square roots. Then I continue again. This is found between, and then I simplify this. What is the square root of negative 81? The negative stays outside. The square root of 81 is 9. And then here also the negative stays outside. The square root of 64 is 8. And those are your answers. There goes your 2 marks right there. Hope that makes sense. You see that? That's how you answer that. Easy as that. Now 1.2. 1.2 is a tricky question, but it's not appearing like this for the first time. I've seen it appearing like several times this way. Right, so here's what you want to do. Right, firstly, they say that show that 0.9, and you can see that this is a 0.9. There's a dot above there, which means this 9 is recurring. Right, this is actually 0.99999 continuing up to infinity. Right, so not up to infinity, but in infinite values there. So now here's what I'm going to do. What I want to do is that I'm going to say, let my x be equals to 0.999, like with the same thing. You see that? So we can see what's happening there. This is my first step, and it's a very polite way to start this day. Now, what is the next thing I'm supposed to do? I'm going to say now that if I take this number, which is x, I multiply it by 10, this number here, which is x, which is not a number. If I take this variable and multiply it by 10, I'm going to have 10x. Right? And if I take 0.99, let's put it in perspective. Remember, what you do on the left, you also have to do it on the right. So let me pick out a calculator here. If I take 0.999999999, I multiply that by 10, I'm going to get, wait, this is not true. This is rounded off. What a time not to trust calculators. If I take this and multiply it by 10, it's going to be 9.9999 recurring. Right? Me multiplying this by 10, it's going to give me that. Right? And then afterwards, then I'm going to say, let me remove x on both sides. Right? So I'm going to say 10x. Let me choose a different color here. When I say minus x, I'm going to do that also for this part here, which is equal to 9.999 minus x. Minus x. Right? But then, let's start on the left side. On the left side, what I know is that 10x minus x, that is 9x. Easy, right? But then what's happening here? I already said that in this situation, which is 9.99 all recurring, when I subtract x, I already said that my x is all the recurring 9s. My x, like as you see here, I said let x be that, right? So which means my x, I can substitute x with this number that you see here. I'm going to say minus 0,99999. This is almost like a level 4 question. Now what happens? What happens is that all the 9s that come after a comma will cancel all the 9s that come after a comma here. Which means on this part, I'll only be left with 9. And on the left side, I'll be left with 9x. You see that? All the 9s that come after a comma have been subtracted by all the 9s that come after this comma here. So I'm only left with the 9 here now. And then afterwards, I divide both sides by 9. This is a nice question. Divide both sides by 9. 9 cancels 9. And then this means my x is equals to 1. You see that? So in this situation, I said my x is equals to 0,9999, and then my conclusion ends with x being equals to 1. Therefore, it means 1 is equals to 0,99999. Do you see that? Do you see the trick behind it? I hope it makes sense. So let's move on. The next question I'm going to attack, this question paper here coming from the June 2022 Gauteng paper. Now this is very much doable. It's even one question. It says now, for which values of x will the expression be rational? Remember what we did in this question, whereby we had to show for which values will this be irrational and rational and undefined. That's the same thing they want here, just that this one here, they only want for rational. They don't want for irrational, right? So you're going to do the same thing. You need to end with an answer that doesn't have a surd and it's not undefined, right? So we do that. We test all the values. By now, I'm sure you know this thing, right? So I'm going to say my fraction is 1 all over the root of, it's a root for everything, 3 plus. Instead of x, I'm going to put 0 here. So I'm going to end up with 1 all over root 3. Now, this is irrational. This is irrational, which is not what we want. So it means 0 doesn't work. I substitute something else to get a rational value. I'm going to have the root of 3 plus, this time I'm going to substitute 1. Let me put 1 there. I'm going to get 1 all over the root of 4. The final answer here will be 1 over 2. Now 1 over 2 is such a rational number, so I'm going to put it there. When x is equals to 1, I'm getting a rational number. Right? Let's keep on testing to see that to see if we have checked everything actually. So I have 1 over the root of, again I substitute 3, I have 3 plus, this time I substitute 2. Now this is giving me 1 over the root of 5, right? 1 over the root of 5, this is a surd, so this doesn't work. Substitute again. This time I'm substituting the 3. So here I'm going to say plus, this time I'm substituting with the 3. See what I get? I have 1 all over the root of 6. Now the root of 6 is not a perfect square, it's also a surd, so which means this also doesn't work out. So it means my answer here, for me to end up with a rational number, it can only work when my x is equals to 1. Everything else here is irrational as we see it, because I end up with a surd. You see that? Nice question from June 2022 Gauteng, and I'm sure you would have gotten this one mark so easily. Right. Afterwards, so what did I do? I dealt with 2024. I did 2023. Then I went to 2022. Afterwards, I went to 2021, but there was no question paper there. I don't know why the internet doesn't have that. So I was like, okay, let's move on. I went to 2020, but then I just remembered that, remember in 2020, there were no June exams because of our situations, right? And I was like, okay, let me keep on searching. 2019 question 1 didn't have the topic of what is this thing that we're doing? Number systems. So they didn't have a topic of number systems. Question 1 was straight on algebra, different things. And I was like, okay, Let me check another question paper. Remember, you have to search all these past papers. I went to another paper was 2018, and then I found this question. Now, if you see 2018, basically we've answered this question somewhere. So this is like a repetition of things that we've done, but we'll still do it again to make sure that we understand it. Right? Let's start with 1.1. Now that we've done it, it's not going to waste a lot of our time. Question 1 says the value of root 33 lies between two integers. Find those two integers, right? So I have root 33. I know that I must find two values that are perfect square immediately below 33 and immediately above 33. So 36, I know it's a perfect square. 25, I know it's a perfect square. So I'll put them that way. I'll have root 25, the smaller number here, root 36, the bigger number there, right? Afterwards, I substitute. No, I don't substitute. I simplify those. The root of 25 is what? Is 5. And the root of 36 is what? Is 6. There we go. 2 marks for me. Easy. Do we see that? Afterwards, I have question 1.2. Now, if you look at question 1.2, it's more or less similar to, oh no, not this one. It's more or less similar to this one that we did here. Now, if you understood this one, you will be able to understand this one too. Right? So now let's do those. What do I have? I have a story that says convert the following recurring decimal, here it is, to a common fraction in its simplest form. Nice. So I'm going to say, do I need more space here? I don't know. But then let's see. What did I do as the first step there? As the first step, I said I must let x be equals to the number that I have here. The number that I have here is 0, 0.45, 45, 45, carrying on. Remember, this is a recurring decimal because it's 0, 0.45 with 2 dots on 4 and 5, right? So which means this is continuing as 0, 0.45, 45, 45, 45. So I'm letting my x be that, right? So after I've done that now, I need 2 digits to go to the left side of the comma, right? What do I need to do? I'll need to multiply this number here by 100. But what I do on the right, I also do on the left. So I'm going to say x multiplied by 100, that will give me 100x is equals to. And I say this multiplied by 100, I'll have what? 45,45, 45, 45, going on with a pattern like that. Remember, this is recurring, right? Afterwards, what did I do on the other question? I said this number that I have, I removed one x. I removed an x there. So which means also in this situation, 45,45 being carried on, I'll put 2 dots here instead of writing all the 4 5s going on and on and on and on. I'm going to also subtract x here because what I do on the left, I also do on the right. Now, what am I getting? I'm going to get 99x here. But then here, I need to make these like terms. So what do I have? I have 45,45 that is recurring. And it's going to be, let me choose a different color. It's going to be subtract this number here. But what is x? X is the number that I see above there, which is 0,45, and the 45 is recurring this way. So now when I subtract these values, all the numbers that come after a comma will subtract all the numbers that come after a comma here. So which means this value now no longer has numbers after a comma because they are cancelled by all these numbers after a comma. What am I getting? I'm now getting 99x being equals to 45. And now I have to solve for x. How do I solve for x? I'm going to divide both sides by 99. Divide this by 99. Divide this by 99. And I have 99 cancels 99. I'm left with x being equals to. And then this I can just put on a calculator, or you can simplify if you have the time, but it's not worth it. Just put that on a calculator, which is 45 over 99. And that gets you 5/11. There we go. My answer here is 5/11. 11. Good marks there. See what we said? The more you practice these things, the more you'll get them. And by the time you get to the final question or to the final paper, you would be used to these questions. So I didn't want this video to take too long. I hope you learned something about this topic that we have here of number systems. So go back and answer all the past papers, and then on the next video, please make sure that you pause the video, attempt the questions on your own first before you proceed to see the solutions. That's all from me today, guys. See you on the next video. Don't forget to like and subscribe. Goodbye for now.